Welcome to the Pro Tips video series designed to arm biology learners with the background knowledge needed to succeed during upcoming lessons. Students are encouraged to watch these tutorials before attending lecture on the topic and rewatch them while studying. I'm Professor Workman, and today's Pro Tips will help you draft hypotheses and predictions prior to running experiments. Recall from a previous video that a hypothesis is a potential explanation for something you have observed. It is stated as if you think it's true, even though you might not be sure yet. So this young scientist may observe that the leaf in his jar is big. This might spark curiosity, and he might wonder, why is this leaf big? An explanatory framework that comes to mind might have to do with the amount of sunlight this leaf grew under. Perhaps the leaf is big because it grew in full, direct sunlight. Some plants like that. This explanatory framework, the because statement, is his hypothesis. If this hypothesis is accurate, then what do you expect to observe? Predictions are predicted observations. One way to test this hypothesis is to measure leaves of this plant that were grown in various light conditions. So here I've selected full sun versus shade. Leaves grown in full sun are bigger than leaves grown in shade. And full sun is a gardening term that refers to areas that get sun in both the morning and afternoon. So to test this hypothesis, you would go out to where many of these plants are growing, and you would measure their leaves. You would also record whether each plant is growing in full sun versus shade. The only observation that would support this hypothesis is if leaves grown in full sun tend to be bigger than leaves grown in shade. Any other trends observed would refute your hypothesis. For instance, if the leaves you measured tended to be smaller in full sun than in shaded areas, then that refutes your hypothesis. Or if the leaves you measured tended to be the same size in full sun and in shade, that would refute your hypothesis too. A prediction, then, is a detailed expectation derived from your hypothesis. Predictions are what you expect to observe during your experiment if your hypothesis is true. If your predictions come true, then your experimental results support your hypothesis. But if any other outcome happens, your experiment will have refuted your hypothesis. And that is what often happens. In our plant example, you can brainstorm other factors that affect leaf size. If our full sun idea didn't pan out, then what shall we test next? Perhaps how much water the plant received or the quality of soil in which it was grown? The process of science is how we narrow down the possible explanations, one failed hypothesis at a time. In summary, you refreshed your prior understanding that a hypothesis is an explanatory framework that attempts to make sense of known observations. From this hypothesis, you can derive predictions, which are the observations you expect if that hypothesis is true. When predictions come true, then they support the hypothesis, but oftentimes they don't, and any other experimental outcome refutes the hypothesis. Thanks for watching. If you liked this video, you might consider watching other videos in the series. Here's my contact information, and I always welcome any feedback. mworkman@pima.edu. Good luck in your biology journey.